Hello, still on machines. We are looking at different types of machines. We have discussed some already. So in this particular class, we'll still discuss more on types of machines. This is Nobleman Science Tutors Online. You are welcome to our class for today. Please, if you have not subscribed before, subscribe to this channel. If this is your first time of visiting this channel, we welcome you to our channel. And in this channel, we are bringing physics class direct to your doorstep. So please, you can invite your friends. If you like what we are doing, give us a thumbs up, give us a like. Click on the notification button so that after you have subscribed, click on the notification button so that once we upload any new video, YouTube will notify you. This is Nobleman Science Tutors Online. You can reach us through the WhatsApp number that is showing on your screen. So get your writing materials ready so that we'll go straight to our class for today. My name is Otobo Michael, so welcome to the class. So we are still looking at different types of machines, and for this class, for now, we are looking at inclined plane. And know that many people will not know that an inclined plane is a machine, but you know that when you want to lift some object, especially maybe you want to roll a drum into the back of a lorry, it is easier for you to use an inclined plane, right? So with the inclined plane, we just roll it and it will go straight to the back of the truck. Or if you want to offload drums, it is easier with an inclined plane. So an inclined plane is used to lift heavy load into trucks or vans. So examples are slope, a hill, and a ramp. A ramp is used in a barge. So if you have seen a barge before, you see a ramp. So many barges have ramps. Alright, many barges have ramp. So these are different types of inclined plane. So what is important in an inclined plane is the velocity ratio. Velocity ratio is distance moved by the effort all over distance moved by load. So the distance moved by the effort in this instance is the length of the inclined plane, and the distance moved by the load is the height of the inclined plane. So velocity ratio is equals to length of the inclined plane all over the height of the inclined plane. But if you look at your trigonometrical ratios, you will see that sine theta is equals to h over L. So, and 1 over sine theta is equals to L over h. So which means that velocity ratio for an inclined plane is equals to 1 over sine theta, right? Based on this equation that is here, velocity ratio is equals to 1 over sine theta, which is L over h. So for a frictionless inclined plane, velocity ratio is equals to mechanical advantage, which is equals to 1 over sine theta. So what you really need to take note of for inclined plane is the equation for velocity ratio. This is what you want to take note of. Velocity ratio of an inclined plane is equals to 1 over sine theta. Is that okay? So if you are clear with that, we can solve one problem also. So this is a question. This is a question just to drive on what we had just discussed concerning or regarding a inclined plane. Okay. So we've said that the floor of a lorry is 2.0 meters high. A plank 5 meter long is used as an inclined plane to raise some load up the lorry. If the efficiency of this machine is 50%, what is the minimum effort required to raise a 200 Newton load up the plane? Okay, so my drawing might not be too good, but please, you just pardon me so that we can do something. Okay, so this is your your inclined plane. Then we are told that the length of the plank is 5 meters. Then the height is 2 meters. So this is what they have said. And they have said that the efficiency of this system is 50%. Okay, and we are also given that load is equals to 200 newtons. So I'm just bringing out the variable that are given to us. Then we also asked to find effort. This is what we're asked to find. So if you look at all that is has been given to us, what is required of us to do first? We are required first of all to find the velocity ratio of this machine. Okay, so the velocity of this ratio of this machine is the distance moved by the effort, right? Distance moved by effort all over distance moved by load, and this is equals to what? 5 over 2. 5 over 2. So, and that gives us 2.5. So with this, we have gotten the velocity ratio to be what? 2.5. Okay, so for us to find the effort that is required, we know that efficiency is equals to load over effort times 1 over velocity ratio times 100 over 1. So efficiency is given to you, load is given to you, effort that is not given, we have calculated the velocity ratio. So you can easily substitute your values here, that 50 over 100 is equal to what? Load is 200 Newton all over effort that you are looking for, multiplied by 1 over 2.5, which is the velocity ratio we just got. So from here, you can make your effort the subject formula. We've solved similar problems before. So this will give us 200 multiplied by 100 all divided by 50 multiplied by 2.5. So by the time you work this out, your effort will be equals to 160 Newton. 160 Newton. So I hope this is simple and you see how we were able to get the velocity ratio from the information that was given to us. From there we started solving for the effort. Okay, so one key thing is that once you understand the question that is given to you, it is always easy to know which formula to apply, and you should know where the question is coming from. You should know whether the question is on machines or just know where the question is coming from. Then try to relate the question with what you know, and then before you know it, your solution will just come out. Okay, so let's solve another one, or let's look at another machine. Okay, so this is another question. This one, an inclined plane of angle 15 degrees is used to raise a load of 4,500 through a height of 2 meters. If the plane is 75% efficient, calculate 1, the velocity ratio, 2, work done on the load. Work done on the load. Okay, so from this particular question, we are given the efficiency of the machine. I'll give you the angle of inclination to be 15 degrees. Efficiency is given to us to be 75%. height to which the load is raised is 2 meters, and the load is 4,500 Newton. These are the information that have been given to us. Now they say you should find the velocity ratio of the inclined plane. One, velocity ratio of an inclined plane is given to you to be what? Velocity ratio is equals to 1 over sine theta. Is that not? Yes. So velocity ratio is equals to 1 over sine 15 degrees. Okay, so just work that out. So that gives you 3.86 as your velocity ratio. Sine 15 degrees, 1 all over sine 15 degrees is equals to your you can solve that. Let me 15 degrees sine, find the inverse. Okay, so that gives us 3.86. Then you cannot find the work done on the load. The work done on the load is the work inputs. And the work output is the work that the machine does. The work that is put into the machine is the work done on the load. Okay, so we know that efficiency is equals to work output all over work inputs multiplied by 100 all over 1. So efficiency is on 5%. Once you write it here over 100, this 100 here cancels out. So that will give you your work output is 450, 4,500 times the distance moved, first times distance, all over work inputs. That's what you are looking for, right? So your work inputs or work done on load, make that the subject. That gives you 4,500 multiplied by 2. That should be 9,000 times 100 divided by 100 divided by 75. Divide by 75. This is divided by 75. So when you work that out, you have 1,200, 12,000 joule or 12,000 kilojoule, as the case may be. Okay guys, so this is just how to go about this kind of problems. Please, I will encourage you to continue to try your hands. You saw how we got the velocity ratio, then how we now apply this other equation to find the work inputs. Is that okay? So this is how to use these equations to solve problems. Okay, so this is another type of machine, the screw jack. This screw jack is what you use to lift your car. Okay, we use it to lift your car. You also have like your bolt and nuts and your engineering vice. All these ones, they are examples of screw systems or screw machines. So one thing that you want to take note of in the screw machine is that the distance between the threads, is called the pitch. Then the distance that this turning bar travel, this turning bar, as you are turning it, this screw, the thread, they will either be moving up or be moving down. Is that not so? So you use this screw jack to actually lift loads. Now, so assuming this is your car, as you are turning it, the tread will be moving. So the distance between the tread is called a pitch. Why the turning bar will move round. So when this turning bar moves through one complete circle, this pitch will move through the distance that the tread will move will be equals to one pitch. Okay, so the effort times distance moved by the effort. Distance moved by the effort is the circumference of a circle. So effort times distance moved by effort is equal to load times distance moved by load. When the effort moves through one circle, the load will move through a pitch of the tummy bar. It will move through a pitch. So effort and distance moved by effort is equal to load times distance moved by load. The distance moved by the load is the pitch, and the distance moved by the effort is the circumference of the tummy bar. Okay, so effort times distance moved by handle, which is the circumference, is load times the pitch. Okay, so if you put this out as an equation, you're going to have this circumference distance moved by the tummy bar all over distance moved by load. So distance moved by load by tummy bar is the effort, distance moved by effort, and the pitch is distance moved by load, and that gives you the velocity ratio. So what you are really looking for here in most instances is the velocity ratio first. So know that the velocity ratio of a screw is equals to 2 pi radius all over pitch. 2 pi radius all over pitch. Is that okay? So the distance between each successive thread is the pitch. So this is the formula for the velocity ratio of a screw jack. 2 pi radius all over pitch. We are going to use this for now to solve some problems. So this is a sample problem that we need to solve. The pitch of a screw jack is 0.5 centimeters. The arm is 50 centimeters long. This arm is the radius of the tummy bar, and its mechanical advantage is 250. What is its efficiency in terms of pi? Okay, so in this particular question, you are be given that your pi is not given to you. So because it says you should find the efficiency in terms of pi, then you are also given the pitch to be equals to 0.5 centimeters. Then you are given the length of the turn bar gives you, which is the radius. That represents the radius. So the radius is 50 centimeters long. 50 centimeters. Then you are given mechanical advantage of the equipment to be equals to 250. So these are what have been given to you already. So from here now, what you do first of all, you need to calculate the velocity ratio. So velocity ratio is given to you to be 2 pi r all over the pitch. Okay, so 2, they said in terms of pi, so you put pi there. Radius is what? The radius is 50 centimeters. Your pitch is 0.5. Okay, so when you work this out, you will have that your velocity ratio is equals to 200 pi. Don't forget that we are solving in terms of pi. So you are going to have 200 pi. Now, your efficiency is equals to mechanical advantage all over velocity ratio multiplied by 100 over 1. So if you substitute these values that you have, mechanical advantage is 250, velocity ratio is 200 pi times 100 all over 1. This will cancel out. So by the time you work that out, you are going to have that the efficiency of the machine will be equals to 125 all over pi in percentage, because it says you should find your efficiency in terms of pi. So this will be the efficiency of the machine in terms of pi. You see the way we went through this problem, so please take notes and apply. Right, so we're moving to another one now. Wheel and axle. The wheel and axle system. In the wheel and axle system, this is a kind of machine that is used to lift water from a deep well, and you have two wheels, the larger wheel and the small wheel. So what you are taking note of here is the velocity ratio. The velocity ratio for a wheel and axle system is the radius of the big wheel all over the radius of the small wheel is equals to the velocity ratio. Okay, so why is that? The distance moved by the effort is the circumference. So the distance moved by the effort through the big circle, or the distance moved by the effort through the small circle. The small circle is the radius of the axle, which is the load. Then the radius of the wheel is the effort. So by the time you cancel that, this is 2 pi big arrow, and this is 2 pi small arrow. So all this will cancel out, and what will remain will be arrow over small arrow, and that's why you have this as your velocity ratio. Is that okay? So let's solve a problem straight away. Right, so this is a sample question that we need to look at. It's a sample question we need to look at. A wheel and axle is used to raise a load of 500 Newton by the application of an effort of 250 Newton. If the radar of the wheel and the axle are this are 0.4 and 0.1 respectively, the efficiency of the machine is what? Okay, so here you are be given the load. Load is given to you to be 500 Newton already, and the effort is also given. So you already know the effort to be 250 Newton, but velocity ratio is not given to you, and you are asked to find efficiency. You are asked to find efficiency. Okay, you are asked to find efficiency. All right, so velocity ratio in this wheel and axle is equals to big radius all over small radius. So you are giving big radius to be equals to 0.4 centimeters, and small radius is given to be 0.1 centimeters. So for this one you have 0.4 all over 0.1. That gives you velocity ratio of 4 for this particular machine. So efficiency, which is what you are looking for, is equals to load over effort 500 over 250 multiplied by 1 over velocity ratio times 100 over 1. So by the time you work this out, calculate all this out, you are going to have 50% as the efficiency of this machine. So you have 50% as the efficiency of this machine. I hope this one is clear, and then you see the way we maneuver through to solve this problem. Okay, so I hope that one is clear. So now you have your test page. All these questions covers all that we have discussed. So I want you to solve them. Go to the WhatsApp page and put your answers there or in the some comment section. Get across to us so that we can discuss and see how we can help you further in your physics learning. Is that okay? You can call us through the WhatsApp number. I will attend to your calls, then see how we can assist you so that you get more understanding of physics. So we are stopping our class for today here. If you have not subscribed, please don't hesitate. Subscribe, give us a like, click on the notification bell so that when we upload a new video, YouTube will notify you. Give us a like, give us a thumbs up. That a thumbs up. Is that okay? The thumb that is up, just click on it. Hmm? So thank you very much. Invite your friends so that they can also come and enjoy what you are enjoying on YouTube. We appreciate you so much for staying with us, and this is a project that we are working on and will continue to bring out the best so that you enjoy your physics classes, and we'll try as much as possible to make this class as simple as possible. Okay, so thank you, we appreciate you, and see you in our next class.